Good day everyone, here is your engineering student Maria Margaret C. Malazarte from BSCE 2B, and in this video I will discuss with you the second module of our Engineering Utilities 2 entitled Building Electrical Materials and Equipment. This report focuses on the various components involved in the electrical infrastructure of buildings from power transmission down to end-user devices. Are you curious about how electricity works? How it is generated and transferred to our homes? If you are, then you are in the right video.
There are actually a variety of ways in which electricity is generated or made. It could be in solar panels, wind turbines, biomass, hydroelectric, nuclear, and fossil fuels. And then there is also a geothermal energy, tidal power, and wave power as well. It has also been said about 80% of the world's energy comes from fossil fuels. First, we're going to have a look at burning fossil fuels in power stations to generate energy. And then we'll look at the national grid, which is relevant for both non-renewable and renewable energies. Fossil fuels in power stations. Most power stations use coal as an energy source and they work in the following way. Coal is burned in a power station. The heat produced as the coal burns is used to heat water. The water boils and turns into steam. This steam is used to turn the blades of a turbine. A turbine looks like a fan or a wind turbine. The turbine turns a generator. Inside, wires turn within magnets to generate electricity. So that was a fossil fuel power station. These next steps are for energy generated from any source, whether it's fossil fuels or renewable like wind-powered substations or biomass fueled. The electricity, whether renewable or not, is passed through transformers and wires within the national grid that carries it to our homes. So now, what exactly is the national grid? The national grid is a system of cables and transformers linking power stations to consumers. Have you ever felt an electrical wire and noticed it gets hot? This is because some energy traveling through the wire is lost as heat. In order to lose as little energy as possible, transformers are used. When the electricity leaves the power station, it passes through a step-up transformer. A step-up transformer increases the voltage and reduces the current. Reducing the current makes the transfer of electricity more efficient as less energy is lost as heat. Before the electricity gets to our homes, the voltage needs to be reduced back down to a safe level. The electricity therefore passes through a step-down transformer. So now you know how electricity is generated and sent to our homes. It's not quite as simple as we think it is. Quite a lot of infrastructure is needed. There's no time in our lives when we don't use electricity. It has already become a basic need in our daily activities, from lighting our homes to charging our phones. Electricity is very useful, but if we overuse it or handle it carelessly, it can also be dangerous. Because of this, we all have a responsibility to learn the basic things we need to know about using electricity safely. To continue, let's talk about the overcurrent protection devices, or the OCPD. They safeguard the building service or an individual circuit from excessive current flows. It protects the circuit components from severe overheating when current flowing through the circuit reaches an amperage that will cause an excessive or dangerous temperature rise in conductors. Fuses and circuit breakers serves as automatic overcurrent protection devices. They are designed to open a circuit if the amount of current in amps that flows through the circuit exceeds the OCP device rating. In simple terms, too much electricity flowing in a wire can cause it to overheat and can lead to burnt wires, fuses, or broken appliances. OCPDs like fuses and circuit breakers work like safety switches. They automatically turn off the power when there's too much electricity flowing, so the wires and devices don't get damaged. Now, before ending this video, I will share some recommendations. First, always choose the right materials. Use high-quality wires, switches, breakers, and other parts that match the needs of the building. Don't use materials that are too small or not made for the job. They can cause accidents. Second, follow the Philippine Electrical Code, or the PEC. The PEC gives the correct rules for safe electrical installations. It helps avoid short circuits, overloading, and fires. Third, let qualified electricians do the work. Installing electrical systems is not a DIY job. Professionals know how to do it safely and correctly. Lastly, use overcurrent protection devices in every system. These protect your home or building from fires and electrical damage by stopping the power when there's too much current.
As engineering students, we need to know how each part works, when to use it, and how to keep people and property safe. This ends our video. I hope you learned something out of this. And again, this is your engineering student, Maria Margaret C. Malazarte. See you when I see you.